What are the challenges in creating ML data? Welcome back to our AI journey. Today, we're diving deep into the unsung hero of machine learning data. Without it, your ML models are like a car without gas, shiny but stuck. In this lesson, we're peeling back the curtain on data management and zooming in on the gritty work of collecting and prepping data for training. Buckle up as we tackle the big hurdles and clever fixes tied to data quality. Let's make sense of the chaos. Data preparation, the heart of the ML workflow. Picture this: an AI is only as smart as the data it's fed. Feed it junk means garbage, in which leads to garbage out. Feed it gold, and you've got an AI genius on your hands. That's why data preparation is the backbone of machine learning. Fun fact: a whopping 43% of an ML team's effort goes into wrangling data, while only 17% is spent on picking and building the model itself. Yep, it's a grind. Tons of manual elbow grease and detective work go into it. So, what's data prep all about? It's the magic trick of turning raw, messy data into something an ML model can actually use. This process powers everything: training, testing, predictions, you name it. Tweak the prep, and you're retraining the model from scratch. It's a 3-act play: procuring the data, polishing it up, and pinpointing what matters. Each step's a beast of its own, and we'll break it down with a tester's eye. Because quality assurance isn't just for the endgame. Act 1. Data procurement, where it all begins. First up, getting the goods. Public data sets like IMF financial data for stock predictions, proprietary data from sensors, or APIs for real-time feeds. For gathering, discuss challenges like data silos and solutions like robotic process automation taking 25% of project time, which can be eased with active learning, where models select informative samples, or crowdsourcing via Amazon Mechanical Turk. For example, for self-driving cars, labeling radar and video data is tedious, but active learning reduces effort by focusing on ambiguous cases. Thus, data procurement is like a treasure hunt with 3 key moves. Identification. What data does your ML model crave? For a self-driving car, it's a mashup of radar pings, video feeds, and LiDAR scans to nail distance. Step 1 is figuring out what's on the menu. Gathering. Where's it coming from? Are you strapping cameras to cars yourself, buying a stash from a vendor, or rating a freebie like IMF financial data for stock predictions? You've got to map the sources, nail the channels, and make sure the pipeline doesn't leak. Labeling. If you're doing supervised learning, every data point needs a tag, like a post-it note saying this is what it means. Unlabeled data? That's hours of hand labeling ahead. Think of time series like stock prices or weather stats. Tedious but critical. This is where the rubber meets the road. Get it wrong, and you're building on quicksand. Act 2. Pre-processing. Cleaning up the mess. Next, we roll up our sleeves for pre-processing. Raw data is a wild child, full of quirks and flaws. Here's how we tame it. Cleaning errors sneak in everywhere. A typo in a form, a busted sensor spitting nonsense, it happens. You're hunting duplicates, outliers, or just plain wrong numbers. Sometimes you ditch the bad stuff. Other times you patch it with a solid guess. Think averages or medians. Oh, and don't forget to scrub personal info for privacy's sake. Transformation. Data's got to speak the same language. Celsius versus Fahrenheit, pick a side and convert. Dates flip-flopping between formats, standardize it. ML loves numbers, so turn words into digits or binary codes. Snip out useless fluff like random patient IDs. Focus on what moves the needle. Normalize or standardize the numbers and watch your model purr. Augmentation. Need more data. Fake it till you make it. Twist existing stuff. Rotate an image. Zoom it. Tweak it. It bulks up your dataset and toughens your model against sneaky attacks. But if your starting pile's tiny, this trick's got limits. Sampling, too much data, trim it down. Grab a slice that still mirrors the big picture. Every group, every trait, still in play. A medical dataset better balanced sick and healthy, or you're toast. One slip here, and you're risking fake data sneaking in or real gold getting trashed. Precision's the name of the game. Act 3. Characteristic determination. Finding the gems. Before the model feasts, we sift for the good stuff features. 2 steps seal the deal. Feature selection. Not every data nugget matters. Ditch the noise. Irrelevant traits, slow training, muddle predictions, and invite overfitting. Keep it lean. Keep it mean. Oh, and watch for bias traps. Gender shouldn't sway a job app score unless you're courting trouble. Feature extraction. Sometimes the magic's hidden. From pixel chaos, pull edges or shapes. From three-dimensional coordinates, calculate distances. Boil down the fluff into tight, punchy features that pack a predictive punch. Exploratory data analysis, EDA, is your wingman here. Charts, graphs, and heat maps, they reveal patterns and pitfalls. It's not linear. You'll hop back and forth, chasing insights. Worth it? You bet. Nail this, and your model shines. The big challenge is where it gets sticky. Data prep's no picnic. Here's the rogue's gallery of headaches. Domain blindness. No clue about the field? Ideally, the exact area of application of the system to be developed is known before the project starts. The reality is often different. If there is little knowledge about the area of application, it is particularly difficult to determine the features. Data mystery. If you don't know your data's quirks, you're guessing in the dark. If the data to be used and its properties are unknown, it is only possible to speculate about potential data preparation steps, especially during pre-processing. Skill gaps. This stuff's complex. Stats, coding, tools. No expertise, no dice. The data preparation steps are very complex and typically the task of experienced data scientists. In addition to a great deal of experience in statistical and other mathematical methods, programming skills or the use of specialized tools for exploratory data analysis are necessary. If these are lacking, incorrect data can lead to poor or even unusable machine learning models. Junky sources. Digital age or not, unstructured slop is everywhere. In the age of digitization, data seems to be easily accessible. However, we often encounter unstructured or incomplete data sets. Automation woes. Turning manual tricks into slick pipelines. Automating preparation steps that are performed manually with expert knowledge can be a challenging task. In addition, it must be ensured that the production data pipeline is not only scalable, but also has the necessary performance for the production environment. Cost creep time, tools, fresh data, it adds up fast. Data preparation is extensive and consists of the activities of data procurement, data pre-processing, and feature determination. This is time-consuming and can sometimes be costly, especially if new or updated data is to be used constantly. The cost of automating a data pipeline and its maintenance should also not be forgotten when estimating costs. QA slip-ups. Miss an error and your model breaks. Catch it early or cry later. Errors can be introduced into unnoticed data during both manual and automated data preparation. If there is a reduced priority for error checking, the effectiveness of the training and the product quality can suffer. If an error is discovered and rectified early in the development process, it is always better than if it only becomes apparent in the production system and later leads to dissatisfaction among users. Bias bombs, skewed samples can derail everything. Fixing it's a slog. A sampling bias can creep in when determining characteristics if the selected characteristics are not representative of the task or are not represented in sufficient numbers. Discovering and correcting a sampling bias after the model has been developed can be time-consuming and costly. Splitting the loop training, validation, testing. Data is the foundation of machine learning and it's split into three distinct sets for specific purposes. First, the training dataset. This is used exclusively to train the machine learning model, helping it learn patterns and relationships within the data. Next, we have the validation dataset. This mentioned set steps in during evaluation. It allows us to measure the model's performance, think metrics like accuracy or precision, completely independent of the training data. Why is this important? It helps us tune the model effectively and spot signs of overfitting, where the model might be learning the training data too well, but failing to generalize. Finally, the test dataset. This one's special. It's only used at the very end after the model is fully developed. Known as the holdout dataset, it gives us an unbiased check of the model's performance, separate from both the training and validation data. Here's the golden rule. The test data must never be used during training or evaluation. It's kept aside until the final step. Now, splitting the data isn't just about dividing it into three parts. Each set, training, validation, and test, needs to reflect a similar distribution of features or labels. For example, if you're building a cat-dog classifier with 50% cat images and 50% dog images, all three sets should roughly mirror that balance. This ensures the model learns and evaluates fairly. So, how do we actually divide the data? Here's the catch. There's no one-size-fits-all answer. It depends on your project. Let's consider a few factors. How much data do you have? What algorithm are you using? A convolutional neural network for image processing, for instance, needs far more training data than a simple decision tree. Are there resource limits, like computing power or time constraints? These all shape the process. If you're lucky enough to have a massive amount of data, practically unlimited, the focus shifts to time and resources. You might only use a portion of the data to stay within budget or hardware limits. But in most cases, data is limited. Here's how it typically works. First, you set aside the test data set. This holdout set is untouchable during model development. It's your final quality check. Then, the remaining data gets split into training and validation sets. The ratios between these sets can vary. Common splits you'll see in projects range from 60% training, 20% validation, and 20% test, to something like 80-10-10. It's a guideline, not a rule. With smaller datasets, we can be creative. Special splitting methods, like k-fold cross-validation or leave-one-out cross-validation, generate multiple training and validation combinations. We train several models and average their performance for a more robust result. One key principle runs through all these methods: randomness. Randomly splitting the data helps ensure each set is representative. To make this repeatable, we set a random seed, a starting value for the random generator. Documenting this seed lets us reproduce the split later, and we'll explore that in our practical exercise. Here's a pro tip. With small datasets, you might even test different random seeds as hyperparameters. This can reveal how sensitive your model is to the specific split, a valuable insight. To sum it up, training, validation, and test data sets each play a critical role in machine learning. Keep them separate, balanced, and representative, and adjust your approach based on your project's needs. Quality quagmires. When data goes bad. What happens when that data isn't quite up to par? Even the most brilliant algorithms can stumble. Thus, let's dive deep into the shadowy realm of data quality issues, why they occur, how they sabotage our models, and what we can do about it. Buckle up, this is going to be an eye-opening ride. What are the reasons for poor data quality? First up, incorrect data. It's more common than you'd think. From mixed-up units to faulty sensors, swapped columns to a careless slip of the mouse during a copy-paste, mistakes sneak in. The fix? Meticulous care and a second pair of eyes with the dual control principle. But if errors slip through undetected, we can hunt them down by scanning for wild outliers or odd patterns in the data. Vigilance is our weapon. Next, incomplete data. Imagine IT security hiccups, hardware meltdowns, or simple human oversight leaving holes in your dataset. Maybe a connection drops and an entire chunk of data vanishes. It's like trying to solve a puzzle with missing pieces. The picture just won't come together. Irrelevant data is the clutter we don't need. It wastes space, time, and computing power, and worse, it muddies the waters, so to speak. Outliers or useless features can trick the model into chasing ghosts, skewing the results. Data protection issues can stop us cold. No matter how pristine your dataset, if it violates laws or policies, it's off limits. Ethics and legality aren't optional. They're the bedrock of trust. And finally, IT security threats. Malicious actors can slip fraudulent data into the mix, turning a brilliant model into a puppet. It's not just inaccuracy, it's sabotage. So, what's the fallout? When data quality falters, the model suffers. Reduced accuracy is the first sign. Incorrect, outdated, or mislabeled data teaches the wrong lessons. Incomplete or insufficient data leaves blind spots. Irrelevant or unprocessed data clouds the truth. The result? Predictions that miss the mark, or worse. But there are further critical points. Then there's the bias. Unbalanced, unfair, or undiverse data warps the model's view, amplifying flaws in the training set. Duplicate data doubles down on the distortion. It's not just an error, this will lead to prejudice baked into the AI system. Don't forget the compromised model. Deliberate manipulation through security breaches can turn an AI into a liability. Stronger data protection and IT security are our shields against this dark art. The lesson is clear. Data quality isn't just a detail. It's the foundation of machine learning success. When performance dips, don't blame the algorithm. Look at the data, fix the flaws, balance the scales, and secure the system. That's how we build AI that doesn't just work, it thrives. The topics mentioned are key success factors and very challenging. In terms of any help needed, just give NUCIDA a call. Labeling, the supervised learning twist. Welcome to the fascinating world of data labeling. Imagine a machine learning model that can spot a juicy apple from a mile away or flag a faulty widget on a production line. How does it get so smart? It all starts with prepared data sets. Data that doesn't just show up ready to roll. Oh no, it's paired with something special, expected output values. And that, my friends, is where the magic of data labeling comes in. So, what's data labeling all about? It's the art of tagging raw data, like images, text, or files, with the right answers. Think of it as teaching the machine what's what. Sometimes it's done by hand, sometimes with a little techie help, but one thing's for sure, it takes time. Some say up to 25% of a supervised learning project is spent just on this step. Now how do we do it? One simple trick is sorting files into folders. Drop an Apple pic in the Apple folder, a spam email in the spam bin. Boom! It's labeled. It's perfect for classifying fruit varieties or spotting duds in a factory run. But wait, there's more. For trickier tasks, like object recognition, we step up to annotation. Picture this, an image with bounding boxes hugging every object, telling us not just what it is, but where it is. That's next-level labeling. But who's doing all this labeling? That's the million-dollar question. There are a few ways to tackle it. First up, internal labeling. Your in-house crew, developers, testers, domain experts, get hands-on with the data. They know the ropes, and they've got the skills. Then there's outsourced labeling, calling in the pros from outside like NUCIDA for instance. Need special tools or expertise? They've got you covered. Or how about crowdsourcing? Imagine a massive online army labeling data from all corners of the globe. It's fast, it's scalable. But here's the catch. How do you know they're doing it right? That's where the genius of crowdsourcing shines. Give the same data to a few folks. If their labels match, jackpot. If not, it's time for a fix. Let's establish quality control, baby. And don't sleep on AI-supported labeling. Tools, some powered by AI, can pre-label data faster than you can say machine learning. Humans just swoop in to confirm or tweak. Oh, and here's the kicker. Most projects mix it up with a hybrid approach. Start internal, then crowdsource with an outsourced twist. Flexibility is the name of the game. But what if you don't want to label from scratch? Enter pre-labeled datasets. From Kaggle to OpenML, these gems are ready-made for general tasks like object or speech recognition. Just one catch. Check the source and quality before starting your AI project because not all treasure is gold. Now here's where it gets dicey. Incorrect labels. They're the gremlins of ML projects. Why? Humans mess up, AI messes up. A typo sends an apple to the orange folder. Bad instructions confuse the team. Or, plot twist, someone slacking with malicious intent. Even translations can trip us up. Imagine a palm tree labeled as a hand. And don't get me started on vague tasks or complex data. The more layers, the more chaos may be occurring. So, what is data labeling? It's a craft, a blend of art, science, and a little detective work. Whether it's internal grit, outsourced expertise, crowd power, or AI wizardry, it's the backbone of supervised learning. Get it right, and your model will soar. Get it wrong? Well, let's just say even the smartest machines can't fix bad homework. Ready to label like a pro? Let's make some magic happen. And NUCIDA is at your side if you want. Your business is a rocket ship built for speed and innovation, but shaky software or weak AI can ground you. NUCIDA Group, with over 30 years of business background, turns clunky code into seamless systems and raw data into AI power. We boost your business to soar. Software bugs delay you, AI hiccups, like bad data, cost trust, and even more. 80% of AI time is data prep, a bottleneck we break. For banking, financing, healthcare, logistics, or tech, weak links hurt. NUCIDA's AI, QM, and QA wizards cut grunt work by integrating AI power to DB, DECA, Deutsche Börse, Hoffmann La Roche, Kerber, and more to see faster, reliable results. For instance, Pickard & Partners saved 90% on software testing. We're global. London, New York, Frankfurt, Karlsruhe, Bangkok, and Washington, D.C., blending Western accuracy with Asian insight. Ready to launch, or do you have any questions? Write a comment here. Ignite success now.